I have a colleague from another school, also a maths teacher, and he started looking through my videos recently, and he's noticed that, I don't know if you've noticed this, a lot of my videos, sometimes I break them up into multiple parts, and I'll deliberately, like I just did 10 minutes ago, show you a right way and a wrong way to do it, but when they're in separate videos, the right way consistently gets more views than the wrong ways, which is not surprising. You're like, why would I want to watch the wrong way? Well, I'll let you think about the answer to that question, because there's a reason why I show you the wrong way and the right way, like I'm about to do. Now, you all started with drawing a diagram. Well done. To your credit, everyone has a diagram, okay? Not so much to your credit, some of your diagrams are pretty small, but luckily for you, here, less than with the shadow diagram, you can kind of get away with it on this one. There's not as much information to put on there. Not that you necessarily knew that at the beginning of the question. I think you were just lazy. Anyway, let me just rehearse what I think most of you, and certainly me when I was, in year 11 or 12, would have done to approach this question. You draw your intersection, okay, and then you start to account for your information. And here tends to be the way that you do it, sort of in a sequential way. So you look and it says, there's a motor car, okay, and it's away from the intersection, and there's a train, also away from the intersection, right? And they're moving at different speeds, so you write their speeds on the diagram. And you say 40 kilometers per hour and 50 kilometers per hour. Okay, is this looking familiar on your diagram, right? They're moving away, and then it says they're moving away from the intersection. They are 40 and 30 kilometers respectively from the intersection at this particular time. So then you look and you say, okay, well, that makes this distance here, that makes this 40, and that makes this 30. Okay, and then it says, at what rate is the distance between them changing an hour later? So you're like, oh, okay, I need the distance between them. I've already got that. That's the hypotenuse. So you call that x kilometers, whatever, okay? And now you look at it and you think, okay, I have accounted for all the information in the question. Now I'd better begin putting on some, or using calculus language to form some equations that I can use to solve this thing, right? So you think, okay, what do I want? I want dx on dt. No problem so far. Okay, well, most of you have that written down. And then you think, well, okay, clearly I have to get this in terms of some other rates that I have. Well, what are these things? Okay, well, I better give them some names, right? This is a car, and it's this length is changing. So maybe call this length, which is changing, call it capital C. Okay, that's not a bad name for it. Okay, this is a train, so I'm going to call it capital T. Maybe you are not fond of having dt on dt, but you better get used to it, because whenever you talk about temperature, it's always going to be a capital T, and you get a fair few of those. So okay, I now know that dc on dt, that should be, well, it's increasing, isn't it? So it's positive 40. And this is the awkwardly named dt on dt, which is 30. And then you think, okay, all right, I need to relate these somehow, don't I? The strategy we've used in the past is you, for instance, with the base and the height of that trough that we were looking at, right? You're like, wait. These are related in some way, aren't they? Okay, so I can use Pythagoras. I could do it a couple of different ways. I could say that I could go in this direction. I could go that way and try and replace something over there. But then you think, no, wait, not such a good idea to replace x, because we want that in our final answer, right? So don't get rid of x. So you look at one of these guys, you think, okay, well, this is the other side. So I can say t is equal to, well, it's a shorter side, so it's going to be the square root of x squared minus c squared? Yeah? Is that looking about right? So you think, okay, that's good. But then you're like, hold on, wait, I need some derivatives in here somewhere. If, for instance, I wanted to do some work with this and this, how do you differentiate this with respect to type? I've got two variables, they're both changing, aren't they? So this is not a good way to approach it. If you have solved it this way, it's not impossible. It is just extraordinarily awkward, because I named this the too many variables approach. Because, surprise, surprise, it has too many variables, okay? So, being that this is not a great way to approach it, not necessarily wrong, like there's nothing on here that I've said which is factually wrong, it's just not a good setup to actually solve the question, okay? So, how can I do this a bit better, right? Part of the problem was, as we tried to put information on the question, we just went through sentence by sentence, letter by letter, number by number, and started putting things on there. That's not always the best way to go. Okay? We also expected that there would be a certain strategy at the end that we were working towards, and it just didn't pan out for us. Okay? So I'm going to approach it a little bit differently. Okay? And you'll see, number one, the way that I put information on the diagram will be quite different. Number two, the strategy that I end up with will also be different to the previous questions I've shown you, which is why I'm picking it out as an example. Okay?